molecular compounds, formula and name. So we talked about ionic compound, how to write the formula and how to know the names. So in this video we are going to talk over the molecular compounds. So we know that molecular compounds, we have discrete molecule units, like our example we had in the first video when we were talking about these, like benzene. You know, we have our discrete unit, molecular unit. Usually the molecular compounds are made by non-metals. Sometimes we have metalloids with non-metals, but in most cases two non-metals. So how do we name molecular compounds? So it's easier than the ionic compound because you don't need to deal with the charge and how to fix the charge, how to write the formula. In the molecular compound, basically we spell out how many elements we have. Okay, so the first rule, we have to name the first element in the formula first. That's common sense, right? And then the second element gets IDE, just like ionic compound. Okay, so name the first element and name the second element with IDE, like silicon carbide, for example. It's not a very good example, but that fits our first rule. Okay, the second rule says you have to use prefixes to state the number of each element in the compound. Okay, so this is not ionic compound, this is molecular compound, so we don't know how many of each element we have, so we have to mention the number of elements in our naming. Okay, usually we do not mention mono as the one, so we do not mention that, but we have to mention if we have two or more elements on each molecular compound. So these are the prefixes. Usually we do not mention mono, as I said, but we have di, tri, tetra, penta, like pentagon, hexa, hepta, and hepta is the one that you don't get that much, but you have to memorize it. Octa, nona, and deca. That, if you think about decade, it's coming from deca. Okay, so you have to memorize these 10 prefixes, and we use these prefixes to say how many of each element we have in our molecular compound. Usually we do not say mono if we have one. In some cases we do, and that we're going to talk about. Okay, so let's name our first compound using those two rules. The first compound is phosphorus, so we just write the name, phosphorus, and it's one. We do not mention mono if it's one, so it's phosphorus. We have 5 chlorine, right? And it's the second element, and we add IDE to the second element, so it's chloride, and we have 5 of that, so it's pentachloride. Okay, so phosphorus pentachloride, that's the name of this molecular compound. Easy, right? So it's easier on the molecular compound because we do not deal with charges, so we don't think about it, and it's easier to just see how many elements you have and you just write it down. You just have to memorize those prefixes, and then you're good to go. Yeah, note that the mono is often omitted when there is only one of the first elements. Okay, so for the first element, when you have one, you do not write mono. Okay, so next example. So the first element is nitrogen, so we write the first element as the name of the element. We have 2 of that, so it's dinitrogen. The second element is oxygen, and we add IDE to the second element, so it's oxide, and we have 4 of that, so it's tetroxide. So there's something that you have to remember. For oxide, all the prefixes that ends with A, you do not write the A. So instead of writing tetraoxide. So we drop this A and it's tetroxide. And this happens to all the prefixes that ends with A. Dioxide is fine, trioxide is fine, but tetroxide is wrong. Tetroxide. If it's like penta, it's not pentaoxide, it's pentoxide. Okay, so all the prefixes that ends with A, you drop the A and write it as, for example, tetroxide. Okay, so this formula name is dinitrogen tetroxide. So you know the rule is not that hard, but the thing is, now that you've learned about ionic compound and molecular compound, first you have to remember if this is a molecular compound or ionic compound. Then you can choose one of these rules. Sometimes it's easy to mix up. Okay, so when you see the compound, go back to the periodic table, see these two elements that make this compound, and see if both of them are nonmetals, or if you have metalloids and metals, and nonmetals, that's a molecular compound. So you have to follow the rule for molecular compound. If you have a metal, then it's probably an ionic compound. So you follow the ionic compound nomenclature. So there are some exceptions. Just be aware that you do not need to memorize these yet. But these compounds basically found and were popular before we developed this naming system, and the name just stick with them. For example, you know, H2O is water. Nobody says dihydrogen oxide, okay, or dihydrogen monoxide. So we just say water, okay. H2O is water. So that's the one that you definitely know and you have to know. These two also are the ones that we might use more often. So we talked about methane, CH4 is methane, NH3 is ammonia. Okay, and if you remember the polyatomic ions, we've had NH4 plus, which is basically ammonia, getting one more H plus, and it became ammonium. This is ammonium ion. This is ammonia, okay, and this one is methane. And we also have some other examples, and you don't need to memorize these. So this is the schematic how to name molecular compounds. Use your prefix, use the name of the first element, then use the prefix, and then the second element with IDE. Okay, so let's have some example. So OF2, what is the name of the first element? It's oxygen, right? So it's oxygen, oxygen, and then the second element is fluorine. Is on the second one you get IDE, so it's fluoride. Okay, so it's fluoride. One of the things that you have to be careful in your spelling, fluoride or fluorine is UO. The common mistake is writing OU. We do not have any flour in fluorine, okay, that you use in your baking. You do not have that. So fluorine or fluoride is OU, okay. So oxygen, fluoride, and don't forget the prefix. We have two of that, so it's difluoride. Okay, so I want you to go ahead and tell us the name for the second example. Okay, so we have, for the first one, we have phosphorus. Phosphorus. Okay, and we have four of that, so it's prefix, first element, prefix, second element with IDE, right? So we have four of that, so it's tetra phosphorus, and we have 10 oxygen, and as the second one it's oxide, so it's deca, and I know it's oxygen, so I don't write the A, So it's decoxide, right? Tetraphosphorus decoxide, P4O10. Okay. Okay, so if we have the name, how do we write the formula? It should be very easy. So the first one is carbon. I write carbon. It's tetrachloride, so it has 4 Cl, so Cl4. Okay. So you tell me the second one. What is sulfur hexafluoride? So it's S sulfur and it's fluoride, and we have 6 of that. Hexa is 6, so it's SF6. Okay, now let's have some example. So first, when you see a formula, the first step is to figure out if it's ionic or molecular compound. Okay, so you tell me, BCl3, is it ionic or molecular? So if you said 2, you're right. Well, boron is not a non-metal, but it's a metalloid, and when you have metalloids with non-metal, we still have molecular compounds. Okay, so BCl3 is molecular compound. Okay, so how do we name BCl3? So if you said 3, you're right. If this was an ionic compound, it would say boron chloride or boron 3 chloride. Okay, it depends. If you have like multiple charges, we use the Roman numeral. If it's not, we do not use it. But basically, this is a molecular compound, so we do not follow these two rules. We use the molecular compound nomenclature. So using the first element, boron, and the second element, chlorine, become chloride, and we have 3 of that, so it's trichloride. Okay. Okay, so tell me if iron 3 sulfate is ionic compound or molecular compound. So if you said 1 ionic compound, you're right. So iron is a metal, and sulfate is not a non-metal, but it's a polyatomic ion. Okay, so iron, a metal with a polyatomic ion makes an ionic compound. Okay, so now let's see if you know the name of these compounds. Well, not the name, but the formula. So give the formula for iron 3 sulfate. So if you choose the last one, you're right. So we have, so for naming if you remember from the last video, for writing the formula for ionic compound, first we have to write the ion. So it's Fe3 plus. How do I know it has 3 plus charge? Because of the Roman numeral, it says iron 3, so it's Fe3 plus. And sulfate is one of the polyatomic ion you have to memorize, so it's SO4, and you have to know the charge is 2 minus. Okay, that's sulfate. Okay, so if we do our crisscross, this goes there, this goes there, so Fe2 and sulfate, when you have polyatomic ion, you have to put it in the parentheses because the number goes for the whole thing. Okay, so SO4 3 times, so that's the formula for iron 3 sulfate. Again, memorize the polyatomic ion. Sulfate is SO4. If it's sulfite, is SO3 2 minus, and sulfide IDE is the elemental sulfur that comes second, so it's S2 minus. Okay, so you have to be careful with sulfate, sulfide, and sulfite. Okay, as the last slide, we are going to talk a little about acids, and it's a little bit complicated, but we do not want you to remember the complicated ones, so we just go through it a little bit. So what is acid? Acid is basically a compound which produce H plus ions when dissolved in water. Okay, so that's one of the definitions. There are many definitions for acids. We have Lewis acid, we have Bronsted-Lowry acid, but we're not going to go into it for now. So some of the properties of acids, all acids are sour. So if you've tasted anything sour, it has acids in it. Orange juice, sour, it has acid. Vinegar, it has acid. But I don't want you to go into the lab and taste everything. But everything that you've ever tasted and it was sour, it had some kind of acid in it. So most of them can dissolve many of the metals, and they can be divided into two main categories. Okay, so acids has H as the first element, and they have two main categories. So we have binary acids and we have oxyacid. Oxyacid are the acid that has oxygen, like H2SO4, for example, or HNO3. They have oxygen in it, so they're called oxyacid, and we're not going to talk that much about these ones. Binary acid are the acid that contains only two kind of elements. Okay, for example, and one of them is hydrogen, of course, as we have it in the first definition. The hydrogen is the first element. So one of them is hydrogen, and it comes with some other type of element as well, like HCl, for example. That's a binary acid. Like H2S. Although we have two hydrogen, but when we say two, we mean two type of element. So it has hydrogen and sulfide. Okay, so it's H2S. Okay, so we have our binary examples. As we talked about it, HCl, H2S are the example of binary acid. For naming the binary acid, how do we name it? So we add the name hydro in the beginning, and then base name of the nonmetal. So the nonmetal, for example, for our HCl is chlorine. We add IC to it, and then we say acid. How do we say that? For example, for HCl, we say hydrochloric acid. Okay, let me write it. Hydrochloric acid. If we had, for example, HF as the acid, so the only thing which is different is the base name of the nonmetal. So it's hydrochloric acid. For HF is hydrofluoric acid. So hydrofluoric acid. Okay, so that's how we name the binary acids. For oxyacid example, we have H2SO4, we have HClO3, we have H, as I said it, HNO3. So we learned about the polyatomic ions as sulfate, chlorate, and nitrate. So we just add hydrogen to it to make them neutral, and the name is just coming with the ions. I don't want you to memorize these names. Maybe you need to name then maybe you need the name of some of these, like sulfuric acid, for example. Maybe you need the name of the sulfuric acid. It's sulfate, so the acid is sulfuric acid. Or we have chloric acid or nitric acid. But you have to know the names for maybe for the homeworks, but it's not going to be in the exam. Okay, so I don't want you to memorize these. But it's not bad to know the name for doing the homework. Okay, so that was the end of this video. We've learned how to name molecular compounds and how to name ionic compounds. The only thing you have to remember is that the first step is to figure out, if you see a formula, is it molecular or is it ionic? Okay, because in most cases, because we learned ionic first, you just go with the ionic method, but you have to figure out maybe it's molecular compound. Okay, so the first step is to figure out if you're dealing with a molecular compound or ionic compound. Then you follow the rules and write the name.